Let's consider the basic cosine function graph. F of x equals cosine of x, or that's the same thing as y equals the cosine of x. And let's first talk about what x is. X is what we can take the cosine of, so x is an angle, and we will consider it in radians. Okay. And then y for this function, y is the cosine of an angle, so y is, in the unit circle, it is the adjacent over the hypotenuse in reference to the angle x. That's the same thing as the adjacent side in the unit circle to the reference angle is always your x-coordinate, your x side of the right triangle, so your x-coordinate over your hypotenuse. And furthermore, in the unit circle the hypotenuse is always 1, so the y-coordinate for this function is the x-coordinate from the unit circle. Now that is very confusing. We're trying to graph this function in the xy plane, but in order to get the y coordinate in the xy plane, we have to look at the unit circle and get the x coordinate. So I hope you're able to follow along as we do that. So let's begin with comparing the unit circle to the graph equals y equals cosine of x, the graph of y equals cosine of x. Let's start whenever x is 0. In other words, the angle is 0. So I'll set up some sort of xy chart here to help us. If the angle is 0 on the unit circle, that means we're here. Y is the cosine of x, or the cosine of 0. So I need the cosine of 0 in the unit circle, and that means the adjacent, the x-coordinate, which is 1, over the hypotenuse in the unit circle, which is 1. So the cosine of 0 is 1. So I get the ordered pair 0, 1, which is up here. And now I want to look at what happens to cosine as my angle goes from 0 to pi over 2. So let's label pi over 2 as my next x value, my next angle. As theta rotates, as the angle rotates from 0 to pi over 2, my x-coordinate, right, my horizontal distance, is getting smaller and smaller and smaller. It was 1, now it's smaller and smaller and smaller, all the way down to 0. So in this part of my graph, my y values have to decrease from 1 to 0 as my angle increases from 0 to pi over 2. So this part of my graph corresponds to this yellow part here. Now let's look at pi over 2 to pi and perform the same analysis. From pi over 2 to pi, my x values start at 0, and now they're getting bigger and bigger as they get close to -1 here. So over here, I have to drop down to -1 from 0. So at pi, I'm at -1, right? My angle's pi. My x-coordinate, my cosine value is -1. The cosine of pi is -1. And so this part of my graph will come down and drop to the -1. And so the green parts of the two correspond to one another. Alright, let's keep going. If I now go from pi to 3 pi over 2, same sort of thing. We can see that as the angle goes from pi to 3 pi over 2, my x-coordinates were at -1, and now they're getting bigger and bigger and bigger until they reach 0. So I need to make my y values grow over here until they reach 0. Okay? And finally, if I look at 3 pi over 2 to 2 pi, my x-coordinates go from 0 to 1, and so I'm back up here to where I started. And so I have one complete cycle of this graph, and if I were to rotate around the unit circle again, it would repeat. So I'd do this sort of thing in both directions. And I'd have this wave going both ways. So the cosine function doesn't start at the origin like the sine function does. It actually starts up here at 1 and then decreases down to -1 and comes back up to 1 at 2 pi.